നമസ്കാരം. അടുത്ത നമ്മളുടെ ക്ലാസ് Simpsons one-third rule for numerical integration ആണ്. എല്ലാവർക്കും സ്വാഗതം. Alright. നമ്മൾ Newton's numerical integration using Newton's forward difference interpolation ആണ് ഡിസ്കസ് ചെയ്തുകൊണ്ടിരിക്കുന്നത്. So now let us recall the general formula for numerical integration using Newton's forward difference interpolation. So this formula is already known to us. N is the number of subintervals, h is the size of each subinterval, y0 is the first given y value or function value, delta y0 is the first difference, second difference, etc. Alright. Now let us consider the special case of n is equal to 2. That means we are finding a special case where our definite integral is evaluated by splitting the given interval into two equal subintervals. എന്ന് വെച്ചാൽ നമ്മളുടെ ഇന്റഗ്രൽ a to b ആണെങ്കിൽ a മുതൽ b വരെയുള്ള ഇന്റഗ്രലിനെ നമ്മൾ രണ്ട് സബിൻറ്റർവൽസ് ആയി ഡിവൈഡ് ചെയ്യുന്നു. So we will consider the case where n is equal to 2. Alright. So putting n is equal to 2, എല്ലാ n-നും നമ്മൾ 2 കൊടുത്തു. n2 എന്ന് പറഞ്ഞാൽ you have 3 y values, y0, y1, y2. അപ്പോൾ അതിൽ നിന്ന് നിങ്ങൾക്ക് ഫസ്റ്റ് ഡിഫറൻസ് കാണുമ്പോൾ ഡെൽറ്റ y0യും ഡെൽറ്റ y1ഉം കിട്ടും. വീണ്ടും ഒരു ഡിഫറൻസ് കാണുമ്പോൾ നമുക്ക് ഡെൽറ്റ സ്ക്വയർ y0 കൂടി കിട്ടും. അതായത് ഡെൽറ്റ ക്യൂബ് y0, ഡെൽറ്റ 4y0 എക്സെട്ര ഉണ്ടാവില്ല. അതായത് നമുക്ക് തേർഡ് ഡിഫറൻസ് മുതൽ ഹയർ ഡിഫറൻസസ് ഒന്നും കാൽക്കുലേറ്റ് ചെയ്യാൻ പറ്റില്ല, സിൻസ് there are only 3 points. Alright. So ആ സ്പെഷ്യൽ കേസ് ആണ് നമ്മളിവിടെ അപ്ലൈ ചെയ്യാൻ പോകുന്നത്. സോ n-ന് 2 എന്ന് കൊടുത്തു, y0 ഞാൻ അങ്ങനെ തന്നെ എഴുതി. n/2 is 2/2, that is 1 delta y0. Then I put n is equal to 1 here, so n is equal to 2 here. 2 into 4 minus 3, that is 2. 2 divided by 12 is 6, so 1/6 delta square y0. So only this many terms will be there in the integral if you are dividing your interval into two equal subintervals. So to evaluate the definite integral, you may split that definite integral into several sub-integrals like this. നമുക്ക് ചെയ്യേണ്ടത് x0 മുതൽ xn വരെയാണ്. നമ്മൾ ആദ്യമേ ഈ ഇന്റഗ്രലിനെ ഡിവൈഡ് ചെയ്യാൻ പോവാണ്. x0 മുതൽ x2 വരെയുള്ള ഒരു ഇന്റഗ്രൽ പ്ലസ് x2 മുതൽ x4 വരെയുള്ള ഇന്റഗ്രൽ പ്ലസ് x4 മുതൽ s6 വരെയുള്ള ഇന്റഗ്രൽ എക്സെട്ര xn-2 മുതൽ xn വരെയുള്ള സബ് ഇന്റർവൽ. അപ്പോൾ ഈ ഓരോ ഇന്റർവെല്ലിലെയും ഇന്റഗ്രൽസിനെ നമ്മൾ ഇവാലുവേറ്റ് ചെയ്യുന്നു. അതിനെല്ലാം സം ചെയ്താൽ നമുക്ക് ടോട്ടൽ ഇന്റഗ്രൽ കിട്ടും. സോ ദിസ് ഈസ് ദ ഐഡിയ. അപ്പോൾ നിങ്ങൾക്കറിയാം, നമ്മളൊരു 3 പോയിന്റുകൾ ഉണ്ടെങ്കിൽ നമുക്ക് അതുകൊണ്ട് കണ്ടുപിടിക്കാൻ പറ്റുന്ന ഹയസ്റ്റ് ഡിഗ്രി ഇന്റർപോളേറ്റിംഗ് പോളിനോമിയൽ എന്ന് പറയുന്നത് ഡിഗ്രി 2 ആയിരിക്കും. ദാറ്റ് മീൻസ് ഇറ്റ് വിൽ ബി എ ക്വാഡ്രാറ്റിക് ഇക്വേഷൻ. സോ ദാറ്റ് സിംപ്ലി മീൻസ് യു ആർ കണക്ടിങ് 3 കോൺസിക്യൂട്ടീവ് പോയിന്റ്സ് വിത്ത് എ പാരാബോള. ദാറ്റ് മീൻസ് 2 കോൺസിക്യൂട്ടീവ് സബ് ഇന്റർവെൽസ് നമ്മൾ ഒരു പാരാബോളിക് ഫംഗ്ഷൻ കൊണ്ട് റീപ്ലേസ് ചെയ്യുന്നു എന്നതാണ് ഇവിടെ നമ്മൾ ചെയ്യുന്നത്. Alright. So how many parabolas? We'll have n/2 parabolas. We'll look into the situation. So as before, let us consider several points. So these are the given points. We need to find the integral from this point to this point. So before, in trapezoidal rule, we connected 2 consecutive points with a straight line. But in this case, we are going to connect 3 consecutive points, that means 2 consecutive subintervals with a parabola, quadratic function. So let us see that. So we interpolate these 2 intervals or these 3 consecutive points with a parabola. Next we choose this point, and this point. Then we will interpolate something like this. Then we will connect these 3 points with some other parabola. So you are replacing your function something like this. Okay. So first we will consider two consecutive subintervals from x0 y0 to x2 y2. x0 x1 is the first subinterval, x1 to x2 is the next subinterval. So we consider the interval subintervals x0 x1 and x1 x2. So the given data points are x0 y0, x1 y1, x2 y2. So from this we can calculate the first difference, y1 minus y0. So y1 minus y0, y2 minus y1. Okay. Then from these two, I can calculate the second difference, y2 minus y1 minus y1 minus y0. Upon simplification, we get it as y2 minus 2y1 plus y0. So using this difference table, we can evaluate the integral of the function from x0 to x2, keeping n is equal to 2. So we have the formula for n is equal to 2. The integral is 2h into y0 plus delta y0 plus 1 by 6 delta square y0. So we are considering the interval from x0 to x2. So looking at the difference table, we can substitute this first y point, first difference, 0th point in the first differences, 0th difference in the second differences. So 2h, I just copied 2h as it is. Then the first y value is y0, so I have substituted that. Then this is the 0th difference, 0th item in the first difference, delta y0, so that is y1 minus y0. Then 1 by 6 into this quantity, y2 minus 2y1 plus y0. So please note that we are considering these points in the table, this one, then this one, then this one. Correct. So these are the points to be considered. Alright. Next, we'll consider the next two consecutive subintervals. Alright. The intervals are x2 to x3, then x3 to x4. The given data points are x2 y2, x3 y3, x4 y4. From these two I can calculate the difference as y3 minus y2, then these two y4 minus y3, etc. Now to evaluate which values are required, this one y0, this one delta y0, this one delta square y0. So these are the required values. Correct. Now let us see. So I am going to make the substitution. Instead of y0 it is y2. So I substituted y2. Instead of delta y0 it is y3 minus y2. So it's y3 minus y2. And instead of delta square y0 it is y4 minus 2y3 plus y2. y4 minus 2y3 plus y2. Fine. Simplifying, you will get it as h by 3 into y2 plus 4y3 plus y4, etc. We will consider all the possible intervals like this. The last two consecutive subintervals are xn minus 2 to xn minus 1 and xn minus 1 to xn alpha. Alright. So the corresponding data points are xn minus 1, xn minus 2, yn minus 2, xn minus 1, yn minus 1, xn, yn. So I'm going to calculate the differences from this and this, yn minus 1 and yn minus 2. You'll get the differences yn minus 1 minus yn minus 2. Delta y1 is yn minus, yn minus, yn minus 1. Then from these two, I can calculate the second differences, yn minus 1 minus yn minus 1 minus yn minus 2. You'll get yn minus 2 yn minus 1 plus yn minus 2. So we need these points to evaluate the integral in these two subintervals. Okay, then this one. Okay, so these are the quantities we need. Okay, we will do the substitution. As before, we have substituted yn minus 2, so it's yn minus 2, then yn minus 1 minus yn minus 2, then yn minus 2 yn minus 1 plus yn minus 2. We substituted respectively for everything. So instead of y0 it is yn minus 2. Instead of delta y0 it is yn minus 1 minus yn minus 2. Instead of delta square y0 it is yn minus 2 yn minus 1 plus yn minus 2. Then upon simplifying you will get these values. Now to get the total integral, that is integral from x0 to xn, what we need to do is we need to add this integral plus etc plus this integral. So we do that. I'm going to sum up. So you can see that h by 3 is a common factor in all the small integrals. So I have taken h by 3 outside, then inside the curly bracket this will be there, plus this will be there, plus this will be there, etc. So y0 plus 4y1 plus y2 plus y2 plus 4y3 plus etc, y4 plus etc. Now we need to find the sum of this thing. So I took the integral I as h by 3. So this h by 3 I just copied. So how many y0 will be there? Only one y0. How many y1s will be there? Here there will be 4y1. Here there will be 4y3. So the odd indexed items will be there 4 times. So 4 into y1 plus y3 plus etc plus yn minus 1 up to yn minus 1. Then you can see that here one y2 is there, here also one y2. So you will have 2 y2, and here one y4 will be there. So the next term will starts with y4. So definitely you will have one more y4. So you will have 2 y4 etc. You will have you will have 2 yn minus 2. So up to this thing. So all the even indexed items are multiplied with 4, so with 2. Then plus there will be only one yn. So this is the formula for Simpsons 1/3 rule for numerical integration. So the 0th item plus 4 times odd indexed y values plus sum of odd indexed y values plus 2 times sum of even indexed y values plus the last y value. We will try one example. So this is our example. Then as before we have the limits from 1 to 2, but here I divided that into 10 subintervals. One important point to be noticed is this: while you are using Simpsons 1/3 rule, you need to take 2 consecutive intervals for evaluating one integral, one sub-integral. So you must have some even number of subintervals to get a better result for Simpsons 1/3 rule. So here I have divided the interval from 1 to 2 into 10 equally spaced sub-intervals. Right. Now this is the formula: y0 plus this item plus, then so I'm going to make every substitution. The h value is the difference between any 2 consecutive x points. So 1.1 minus 1 is just 0.1. Then by 3 I just copied that. Instead of y0 it is 3. Then 4 times even indexed items, y1 that is 3.63, then y3 that is 5.07, then 6.75, then 8.67, then 10.83. right? All the odd indexed y values. Okay, then 2 times 2 into all the even indexed y values. So y2 that is 4.32, then y4, then y6, then y8. We don't want to add y10 because that is the last indexed y value. So up to yn minus 2, then plus yn. So that is 12. Alright, upon simplifying you will get it as 7. As in the previous example, our y values are generated from this function 3x square. 3x square. You can cross check the y values. Okay, so our function is basically a quadratic function, and in Simpsons 1/3 rule we are replacing every 2 consecutive subintervals with a a quadratic function, or in other words parabola. So your actual function is parabola and you are interpolating with parabola, therefore it's natural to get the exact value, and it is in good agreement, so we obtained the same result 7. Please note that in the previous video for trapezoidal rule we used the same function with different h value and different subintervals, but the integral is from 1 to 2, and there we obtained slightly different answer, 7.02 something like that, so which is very much closer to 7 only. At that time I already explained you that in the case of trapezoidal rule we are interpolating with straight lines, that means linear polynomial, but our function, our original function is basically quadratic. Therefore definitely replacing a quadratic function with a linear function will definitely result in some error, so that was natural. But here in this example it is just x square, that is quadratic, and you are replacing this given data points with a quadratic interpolating polynomial, so it's natural that you will get the correct result. So it's in good agreement. That's fine. Thank you.